I have set linrad now to send the resampled baseband signal with 16 bits to the network and to receive it with another instance of linrad. So exit by pressing 0 and then T to enable, and then start playing the recorded file. That's 2. And click on the signal that we are using here, 585 kilohertz at the center here. And on another computer I have it set up like this. And I press F to receive amplitude modulation. And at the center here we have the signal. Now I am sending the frequency range from here to here, and I will turn down the bandwidth. I do that with the yellow mark here while looking at what comes through. You can see the main spectrum becomes narrower. And here the pulse comes wider because of too small bandwidth. And if I go out here, the pulse becomes wider because this is a sweeping signal. It happens to be narrowest at the bandwidth, something like this. I can now try to enable the noise blanker. So this demonstrates a little bit what a narrowband noise blanker can do. I mean, this is a straightforward, simple narrowband noise blanker. I have now changed the transmitting instance of linrad to coherent mode 2. There is a narrow filter, this filter, that selects the carrier, and then it takes the in-phase and the out-of-phase component with respect to that carrier and sends as 2 channels onto the network. On the other computer I received the 2 channels. They come as I and Q, here and here, I and Q, but this is loudspeaker output, the baseband. So it is real valued, so one of them is 0 and the other has the signal. The interesting here is that in the orthogonal part that is sent from the other computer, we have the interference only, while in the first channel we have the AM station plus the interference. So what could be possible is to use the information about the pulses to perhaps subtract something, or at least control how to reduce gain to do a better noise blanker. And I think this is what the vectorial blanker in Perseus is doing. It's using the information that is recovered as the out-of-phase combination of the 2 sidebands of an AM station to correct for what is the pulses. And using the combination of the sidebands, the in-phase combination that corresponds to the upper track here, to become more or less free from the interference pulses. And of course, if I enable the blanker here, it doesn't work particularly well, because the blanker operates on the white track, and that is the sum of the power from both traces, and it's no better than it were before. And we can see here, the red bar is the signal plus noise in the orthogonal channel, the auto phase, while the green is the AM station plus the pulses. I would like to place the threshold something like here, if I could do it for the red bar only. I haven't implemented something like that in linrad, but it is doable, and one could do somewhat better processing than linrad has had before, maybe equivalent to the vectorial blanker that is implemented in Perseus. I have increased the level of the orthogonal channel, that's where the pulses are, by a factor of 5, that's 14 dB. And now the noise floor with the pulses has a similar level as the AM stations plus the pulses. If I now enable the blanker, you see here, you can see that we cut holes at the right positions with some improved precision, although, as you can see here, it's not quite perfect, or let's say quite a bit from perfect. I can bring down the blanker threshold and optimum is something like this. And maybe I can gain something by turning down the bandwidth. It isn't really what we want. It makes some better copyability, but there is a lot more to wish from this.